everyone, and welcome to this video going over lesson 22.4, inverse trigonometric functions. Let's get started. In this video, we are going to discuss how do we find missing angles of triangles? How do we find missing angles? And in order to do that, we have to talk about inverse trigonometric functions. Because if I wanted to get x by itself in this equation, I cannot just divide by cosine. Cosine is a function, which means I have to be doing cosine to a number. Cosine doesn't work all by itself. In fact, if you tried to type in just cosine into your calculator and press enter, it would say invalid because it needs an input. So dividing by cosine does not work. Also, you can't divide by sine or tangent. So in order to get rid of cosine, because I need x by itself, I need to take the inverse cosine of both sides of my function. It looks like this: inverse cosine of x and inverse cosine of 8/16. Because the inverse cosine cancels out the cosine and will leave me with just x. In order to type in the inverse of cosine into your calculator, here are the instructions. You press the second button, then cosine, and then type in your 8 divided by 16. The inverse cosine of 8 divided by 16 will get you 60. And let's think about what this means. We normally find the cosine of an angle. So if we have cosine of x, this is asking what angle has a cosine of 8/16. So because our answer is an angle measure, we need to make sure we put degrees on it. So this says that the cosine of 60 degrees is 8/16. In B, I want to know what angle has a sine of 0.8660. So in order to cancel out sine, I have to use inverse sine, because inverse sine cancels out sine, leaving me with just x. So in your calculator, you would type in second sine, 0.8660, and you should also get 60 degrees. This means that the sine of 60 degrees is 0.8660. Last one, in order to cancel out that tangent, I need to use inverse tangent. Inverse tangent cancels out tangent, leaving me with just x. And the inverse tangent of 1 is 45 degrees, which means the tangent of 45 degrees is equal to 1. So let's see how that we can use this for an actual triangle. Looking at the diagram below, x is my reference angle and it's missing. But I'm going to label my sides from this reference angle. So across from my angle is my opposite leg, which means that 8 is my adjacent leg and 16 is my hypotenuse. According to SOHCAHTOA, because I am given the adjacent and the hypotenuse sides, I'm going to use cosine. And I would set this up like normal. So I would say cosine of the angle, and in this case the angle is x, is equal to adjacent over hypotenuse, so 8/16. And then to solve this, I need to cancel out cosine, so I'm going to use inverse cosine, which leaves me with just x equals the inverse cosine of 8/16. So you would type into your calculator second cosine, 8 divided by 16, and you would get 60 degrees. Let's try another one. For number 2, it says find the measures of angle A and angle B. So I'm missing both angles. Let's start with finding just one. So I'm going to start with focusing on just angle A. And I'm going to label all of my sides from the perspective of angle A, which means that 15 is my hypotenuse. Across from angle A is my opposite leg, and 14 is my adjacent leg. So I have the adjacent and hypotenuse sides. That means that I'm going to use cosine because I have A and H. So I would say the cosine of angle A equals adjacent over hypotenuse. So that's 14 over 15. And then to get angle A, I have to take the inverse cosine of both sides. So inverse cosine, and I would type into my calculator the inverse cosine of 14 divided by 15, and that tells me that the measure of angle A is 21 degrees. Now, we also have to find the measure of angle B. Because we know that angle A is 21 degrees, we have a couple options. One, we could erase our labels and relabel all of our sides from the perspective of angle B and do inverse trigonometry again. Or, because now we know two angles of our triangle and all the angles add up to 180 degrees, we can just subtract 21 and 90 to find what that third angle is going to be. And that third angle, angle B, would be 69 degrees. Let's try one more. In number 3, this is our angle that's given to us. So I'm going to label my sides from that perspective. I have my hypotenuse, my opposite, and my adjacent. I am given the hypotenuse and adjacent sides, which means cosine. So I would say cosine, and that little symbol there means theta. So cosine of theta. Theta is typically used when we're missing angles. Is equal to adjacent over hypotenuse. So 10 over 24. And I need to inverse cosine both sides. And theta would be equal to 65.38 degrees. The last thing we're going to talk about in this video is what it means to solve a triangle. Now that we have techniques to find both missing sides and missing angles of right triangles, we can solve triangles, which means to find all the missing sides and angles. To solve a triangle means to find all the missing sides and angles. So looking at question A, I am missing angle A, I am missing side AC, and I am missing side BC. So I have to think about all the tools that I have at my disposal. That includes the Pythagorean theorem, special right triangles, SOHCAHTOA, and inverse SOHCAHTOA to find that missing angle and those missing sides. Something I also know is that all the angles in a triangle add up to 180. So I can say 180 minus the 49 minus the 90, which tells me that angle A has to be 41 degrees. And in order to find x and y, I'm going to use SOHCAHTOA. So I'm going to use the 41 degrees and label my sides. I have opposite, hypotenuse, and adjacent. And I'm probably going to have to use SOHCAHTOA twice since I'm missing two sides. I don't want to use tangent because I don't know opposite or adjacent. And I can't use SOHCAHTOA if I'm missing both sides. So I'm going to have to use hypotenuse. And let's start by finding x first. So that would be adjacent and hypotenuse, which would be cosine. So cosine of 41 equals x over 27. I then put a 1 underneath my cosine 41 and cross multiply. 1 times x is x, and x equals 27 times the cosine of 41, which tells me that x is about 17.71. I now need to find y. So instead of using adjacent, I am now going to use the opposite in the hypotenuse, which would be sine. So the sine of 41 is equal to the opposite over the hypotenuse. I put a 1 underneath the sine of 41 and cross multiply again. And this says that y is equal to 27 times the sine of 41. And this tells me that y is 20.38. So we just solved this triangle by finding all of the missing sides and all the missing angles. Let's try this one more time. In B, I am missing angle E and angle D and side ED. When you are given two sides of a triangle, of a right triangle, and you need to find the third side, I would use the Pythagorean theorem. So I can say 9 squared plus 15 squared equals x squared. 9 squared is 81, 15 squared is 225, and that equals x squared. Together that makes 306. And then in order to get rid of that square, I need to square root both sides. If you notice in the directions, do you see how it says round your answers? Whenever you see the word round, that means you can just use a calculator. That means you don't have to simplify your radical. You can just plug that into your calculator. And so this tells me that x is equal to 17.49. Now I have to find angle E and angle D. I'm going to start by finding angle E, which means I need to label my sides from the perspective of angle E. So 9 is my opposite leg, 15 is my adjacent leg, and x is my hypotenuse. They give me the opposite leg and the adjacent leg. So if I have opposite and adjacent, I'm going to use tangent. So the tangent of angle E is equal to 9 over 15. And because I'm looking for an angle, I have to use inverse. So I'm going to inverse tangent both sides. And this tells me that angle E is 31 degrees when I round to the nearest degree. Lastly, I also have to find angle D, but because I know two angles now, I can just subtract those two angles from 180. So 180 minus 90 minus 31 tells me that the measure of angle D is going to be 59 degrees. So in this last problem, I used the Pythagorean theorem, inverse SOHCAHTOA, and the fact that all the angles in a triangle add up to 180. So when you do solving a triangle problem, you might need to use a combination of all of our techniques, depending on if you're missing a side or an angle, and depending on which information you already have. So you can get a little creative. Maybe you took a different approach to these problems than I did, which is great. Something I love about math is that there's not always one correct method to solve a problem. And so we're going to practice different combinations and different techniques that we can use to solve a triangle depending on the amount of information you're given. Please let me know if you have any questions, and I will see you in class.